Welcome to PWJ, guys. This session is a build-up of the previous one where we dealt with arithmetic operations. So today we're going to unite or merge all those four functions we defined before to a single function that's going to carry out all those arithmetic operations. At the end of the lesson, you should be able to extend this single function so that you can implement your own. You can add your own trigonometric functions and evaluate the arguments as given in the function. So now, let us start. So today, there are a few changes. I am not using the idle editor as before. So this time I'm using VS Code. It's a Microsoft editor. It's also versatile. It's very good and used in the programming sector. It's more easy to use as compared to idle, because idle is a REPL based programming interface. You type and then it gives you the result. You type, it gives you the result right from that interface, and it's more proper to use for code constructs which have got one expression or single line expressions. You just type and enter, then it gives you the result. So here you can type in multiple lines, and once you are done with that code block, you can go to the console. The other nice feature of VS Code is it has a built-in console, but the console can be hidden or shown. You can choose as you like. You can do it. Let me just show you how. Now I've hidden my console. I've shown my console. You just press Control backtick or Control J. So that's it. Otherwise, it's a free editor. You can get it from this website here, code.visualstudio.com. It's very versatile. I encourage serious programmers to download it. We shall use it going forward, not unless there are other suggestions from you guys. Then for the editor, we shall use python.org as before. We are using Python 3.5. It should be available on that website as well. So for today, we shall do that function as I promised, but before then, there are two concepts I'd like us to master. That is, one, the print statement in Python. That is, how do we print something in Python? How do we print it onto the screen without using that ripple effect or that type and then reply, type, reply effect which we saw in idle in the previous session. So in the case of Visual Studio Code, you'd like to know the command to output the result yourself, because it won't help us. This interface doesn't help us. It just wants us to type. We should know what we are doing. Then once we're done with the printing, we'd like to do conditional execution. So let's go back to the printing here. To print something here, one second. To print something, we use the print operator or the print function in Python. You can say print, then you put whatever you want to print. You can say hello here if you want to print the string hello. There you go. So when you execute, then this line of code in the REPL here, it shall give you hello. But then we can't just execute with this straight English here, because remember, the Python interpreter can only interpret the Python code, not English. So let's first save our file here as a Python file. We'll say file, save as, then we will say functions.py, then save. Let's see. See now, our code editor can even realize that this is a Python line of code, and the other ones it is rejecting, it's just leaving them as white. We'll comment them off. So in your keyboard you'll press Control / that comments them off. This one also, you press Control / then save. So now let's execute this line of code in the repo. So to do that, we'll type Python. I'll use 3.5, then say functions.py. See, there is our hello. It's printed in the repo. You can also print a content which has been assigned to a variable. Let's declare the variable number and put 5 into it. Then you can print that 5 by saying print number. Because it's a variable, there is no need to put the quotes. But if it was a string, you would put the quotes. So let's save that. So the expectation is the hello is going to print, and then the number 5 is going to print. So let's execute that now. As planned, guys, you can see hello has been printed and the number 5 has been printed. Basically, that's how we do printing in Python. So now we're gonna work with conditional execution. With regards to conditional execution, Python makes use of a number of constructs, but for this case, or for our current task at hand, we shall use the if construct. So the if keyword in Python is used for testing the truthfulness of an expression. Say you want to evaluate if the contents of two variables are the same, they are equal, or one is less than the other. You use the if construct. It's more relevant for that. So you can say if something is true, I'll just say true. If something is true, then you do something here. That is, you execute some Python code if something is true. But if that thing is not true, you can decide to execute something else. I'm saying you can decide because Python has no problem with you just saying if something is true, do something. But if you decide that if it's false, you want to do another thing, you can say else. Else, you do something for the else part. Do another thing here. So that's how you can test a certain condition in Python and then execute different blocks of code. But sometimes you may like to do further tests. You can do this test and see if it's true or false. Then depending, in the middle, you'd like to do further tests. The further tests in Python are done using the elif statement. So you type elif, you test again. Elif something else maybe is true, then you do something else. Do something else. The series of elifs can vary. You can have one or more. So you can have more than one here. Let me indent that. So that's the logic. So let's give an example. Let's see how we can make it concrete by the use of an example. Let me comment this thing off. Let me comment this, guys, quickly. Then let's use a concrete example. Probably use a case of two numbers, number 1 and number 2. So we'll use those and see if one is equal to another. Let's declare two numbers. Say number 1 num1 assign 5, num2, sorry for the semicolon guys, I'm from the C-based languages, I use them as well. So number 2 assign, let's say 2 or 4. Then let's test if the two contents of the variables num1 num2 are the same. So you just type if num1 equals to num2. The beauty of the VS Code editor as well is the Intellisense. So here I didn't type the whole num2, and then the editor is speculating to me that I have to type num2. And again guys, I have to emphasize that the sequence of putting these variables here doesn't matter. You can put num1 here or here, or num2 here or here, so it doesn't matter. Equality will be tested in either way. So if they are the same, we'd like to print equal, else we would like to print not equal. Save that. So what's gonna happen really is here, let's try to understand what's gonna happen. So here we've got num1 and num2. So what's gonna happen is here in num1 there will be 5, then in num2 there will be 4. So Python will say, is 5 equal to 4? Then it says no, it's not equal. So it will skip and not execute this part. So it come and execute the false part or the else part and say not equal. Save that. Let's go up and comment off the previous print statements so that they don't clutter our output here. So save. So now let us execute not equal. So it's the same output as we just discussed. Because 5 is not equal to 4, we get the output not equal. So this statement was false. So now let's manipulate our variables such that this part can execute. So let's try to assign into the first variable the contents of the second variable. Let's say num1 assign num2. Save. Now let's execute this. Now they are equal. Why? They are equal because we just put inside variable num2 the number, or inside the variable num1 the number 4. So we knocked off that 5 which was there, so that in num1 there is 4 now. So that is why now they are equal. But then we had stressed before that you can do intermediate tests here by the use of the elif construct. So we can also do further tests before we do the else part. So Python if else elif expression can only have one if condition, one else condition, and multiple elif conditions in one indentation block. So elif, let's do another test here. We'll see what we may test. Elif something, then we'll do something here. So we'll just say print executed elif. Let's remove this part. If so, now we want to test if they are not equal. We want to say if num1 is greater than 4, we want this to execute. So that will be 5 is greater than 4. That will be true. So this will execute. So if num1 is is greater than num2, then execute this. Let's not even say executed, let's say number one is greater than number 2, num2, like this. That's variable names num as well here, so that we can relate. So let's execute. There you go. Num1 is greater than num2 because 5 is greater than 4, which was in num2. Yes, ladies and gentlemen, that is how we do conditionals and print functionality in Python. So now back to our initial task. The task is to unite or develop one function that's gonna allow us to do all those 4 arithmetic operations using one function. So as before, we are going to use the def keyword in Python. So let me comment everything we've done here and then define our utility function. So let's start here. So we're going to say def generic, let's call it generic function, generic arithmetic, then we open brackets, then we will say num1, num2, then our third argument is going to be something called an operator. We'll call it op. Then we'll put the full colon there, then we press enter. So now here we have to check what is this operator, such that we would like to know from the value of this operator, are we adding this, or are we subtracting, dividing, or multiplying? So let's do a test as to what is op. So we'll say if op is equal to a plus, let's do something, we add, so we return something here, return the sum of the two, number 1 plus number 2, like so, number 1 plus number 2, else, because we have got 4 conditions to test, so we do further tests. This was going to work even if we say if 4 times, but then that's not good programming. We'll have to use the elifs. Elif op is equals to a minus, then we do the subtraction. So we return the difference of the two numbers, enter, paste, then just subtract here, yes, then elif, the operator is equals to a star, then we would like to multiply, so let's take that, then we put a star in between. It's easy like that, guys. How easy. You can guess the last one, which is going to be a division. Is it else? No, it's gonna be elif as well, because for the else we are going to put an invalid operator condition, so that we may return something like a -1 or something else to tell us that a problem happened. So we'll say as the If everything fails here, we'll say else return -1. So if we get a -1 for our defined function, we would know that something has happened, something wrong has happened. So let's for now use -1. This may not be the optimal way of returning an erratic option, or of returning a value that would tell you that op was wrong. But for now, this would do for our case, for learning purposes. So that's the function, guys. So to call the function, you just type the code just down here. Or let's run the code and see what happens if we don't call that code. Let's run this. See, nothing happens. So to execute that code, you have to call the function with some arguments, 3 arguments. You say num1, num2, then you say op. So yeah, that's it. Save, then you can execute. But remember, guys, we have not defined num1 and num2, otherwise our program is going to fail. As you can see here, we have to define these first, and op is also not known. So let's do this. Num1 equals to, let's say 2. Num2 equals to 4. The operator is equals to, I would like to define or just pass in the operator here as a direct string, so we can put plus here, but it's equally allowed to do this, and it's neater, but for now I'll put it here. So let's save and then run. See, we are not getting anything. What happened? So the 4 was put into num2, the 2 was put into num1, and the addition was done, but after doing the addition, the function didn't know where to put the number 6, which is the sum of 4 and 2, so it threw it away. So we have to take that and put it in a variable. Let's call that variable sum. Sum, save. Then we'd like to print the sum. Print sum. Save. Or even to make it look neater, I'll show you in a while. Let me just save, and then let me close this. Then let's run this. So now you can see the sum is 6. Now the function didn't throw away the number 6, it had put it in the variable sum, and then it's printing it up here. But throwing in 6 like that sometimes doesn't make much sense to a human being. At least to a computer, the computer knows what it was doing, guys. So let's put the sum is, then we put sum. Let's try to execute this. Now it might make sense to us as human beings. So now it's neat, the sum is 6. So let's do the same for the other arithmetic operators. We copy this, paste, copy, paste, copy, paste. So now here we'll do subtraction, and then we'll say here the difference. The difference is, so we'll put it in diff here. So let's use different variables for the different execution functions. So we'll put diff there. Then for the multiplication, we'll say prod here. Then here we'll say the product is. Then I put prod here. Then you guessed it. Here we'll say for division, we'll say div. Then here we use /. Then here we'll say division. Then here div. If I'm not mistaken, we have done all of them. Let's save. Let's check our output. Let's execute our function and see what happens. Yes. See, the sum has been computed as 6. The difference is -2 because we said number 1 minus number 2. So 2 minus 4 is -2. The product is 8. And the division is a half because 1 over 4 is 2 over 4 is 0.5. Then we have to test. Let's just test as a parting shot this part here, the else part. When does it exactly execute? It has to execute if everything else has failed. So let's pass an invalid operator that doesn't match all those tested up there. So now let's do this. Let's execute our function to test its robustness here. Let's say invalid op. That should be -1 if invalid. You can put anything here. Let's put question mark maybe. So let's say invalid. So then we copy that, save, execute. You see, we get our -1. It means when the program or when the Python interpreter was testing, it got a false here and it didn't execute here. And it checked whether because we passed in a question mark, remember, question mark is not equals to a plus, so this didn't execute. Again, question mark is not equals to a minus, never executed. Same here, same here. So the else part works for conditions where nothing before has passed. Yes, that's how it works, guys. So now there is one last very nice operator in Python. In some C-based languages, it's called a ternary operator. It executes like so. Some of you may know it. So you evaluate an expression on the left-hand side of the question mark. If it's true, then this executes. If it's false, then something after the full colon executes. So Python also has that nice feature. It's called a ternary as well, but its implementation is a little bit different. So let's see how we can implement or do a succinct better version of our generic function using the ternary operator. It will make our code neater. So let's try to do it, or let me type it first and we discuss it later. Def, so we'll say def ternary no ternary generic ternary, how do I generic ternary. So we take the same argument, let's say num1, then num2, comma, then we say op. So we're gonna check all those conditions, but we'll be using a different way of testing. So still we put in the full colon there, then we start the test. So let's go. So we'll just return immediately there. So we'll just say return. Let's type in return here. Return. So num1, we'll start summing num1 plus num2. Return num1 plus num2. That is if some condition is true. So it's kind of like an evasion of the C-based ternary operator. So we'll say we are going to do an addition if some condition is true. So that is if op equals to plus, we are going to add. So that's how it goes. So this colon also should be removed. We should remove this colon. So else we are going to do another thing. Let me copy this because it will be the same going forward. Copy this. Else we are going to subtract if the operator is a minus. Then we subtract. Else we test the other conditions. Else, let me copy that because it's repeating, guys. You'll get the hang of it. Easy and succinct. Let's just take that. Then we'll do the product now. Else is a product. Else multiply if op equals to a star. Else will divide if it's a division, or if it's a forward slash. Else we divide num1 divide by num2 if the operator is a forward slash. Yes, then there is an else again. That last else is the one for the invalid operator. Else if any of the if statements previously didn't match, so you return us a negative one. Let's see if this would work for us. Let's test it. Quite long, but you know, it's just one liner. Let's test how this would work. We can use the same test as before. Let's highlight this. Let's highlight. I'll just like to reuse all these previous tests. Yes, copy that. Then paste it here. Then we'd like to change the name of the variable, the name of the function. This one. Highlight all of them. Control D on your keyboard. Control D. Control D. No, we are not gonna change that. So we start here. Control D. All these. Then we paste here for the ternary. Let's try to execute and see if we are successful. Quite long and tedious. Let's see if we win, guys. Compile, save, run. Wow, there is some change we have to do. Functions.py sum equals to ternary plus generic ternary price is not defined. The name generic ternary not defined. Okay, go up. Let's see. Oh, okay, we had to paste below the function. Made a mistake and paste that immediately there. Okay, copy that, cut that even. Okay, oh yeah, I replaced even the useful one. Okay, 1 second, I had replaced even that generic arithmetic one, but it's fine. Now let's test here. That should be fine. Now let's run this function, guys. See, it works. That's the generic one here, because when you look at the first function here, there is no output. That's the one I cut. So this one worked because we tested before. This one also works for the same output, and is giving us the sum of 4 and 2, 6, difference -2. So it works, but it's very interesting, guys. This one is just a one-liner. It's, you know, that's the power of programming. That's the power of knowing how to use the right tool when the rightful, task avails itself. Now, for this session, guys, we shall end here, but I'd like to challenge you to use the same functionality we have here. The generic ternary, it's up to you, or you use for your own understanding before you go for the generic ternary, the generic arithmetic to do other mathematical computations like trigonometric functions, computation of remainders, modulo operations, and the like. Any other mathematical operation you can think of, just go ahead, just do it. So yeah, we end here for today. We'll continue later, but I would like to urge you guys to please subscribe to my channel, so that we would have more better and informative coding. My plan here is to have at least 2 uploads per week, or even more if you guys enjoy what I'm doing. Thank you so much. Have a great day. Thank you.